put this one on the line. All right, so today we're going to cover the what I call the 30, 45, 60 degree must-know angles, like the must-knows. I'm calling them the must-knows. All right, we're going to start with these two triangles that you have at the top of your page, okay? One triangle is a 30, 60, 90. The other is a 45, 45, 90. So the first triangle over here, my 30-degree angle is down here, of course. My right angle is here, and my 60-degree angle is up there in the top left-hand corner. Now, as we discovered the other day, it doesn't matter the size of the triangle in special right triangles because the ratio is the only thing that really matters. The ratio will always be the same no matter what size triangle we have. So we're going to consider, in both cases, a triangle with a hypotenuse of 1 unit. Okay? So the hypotenuse is 1 unit in both triangles. Now, remember your geometry. If the hypotenuse is 1 unit long in a 30, 60, 90 right triangle, how do you get to the shorter side? 1/2 of 1, which would be a half. Very good. I'm so glad you guys remember that. Now, how do you get to the longer side? 1/2 of rad 3, which is rad 3. Oh my gosh. I don't know what that was. I am not sure what just happened. Okay. Everything still works? Yeah. There you go. Half rad 3 over 2. Okay. Now, let's shift our attention to the 45, 45 special right triangle. Okay. Oh, I lost some things here. That was weird. So, 45 degrees, right? 45 degrees. If our unit is 1, how do I get to the leg of that right triangle? Yeah, very good. Brody, nice job. This will be rad 2. Rad 2 over 2, rad 2 over 2. Okay, I'm going to help you out with figuring out the radian and then do the sine, and then you guys will be on your own, okay? So you'll partner up and do the rest. So here we go. 30 degrees is how many radians, everybody? Pi over 6. Very good. Okay. 45 degrees is how many radians? Pi over 4. Yes, very good. And 60 degrees is how many radians? Pi over 3. Very good. Okay, I'll do the sine for you, and you guys can get together and work on the other ones. Let's consider the sine of 30 degrees, okay? Everything I need to answer the picture is right up there at the top. So the 30-degree angle is here in my bottom right-hand corner. The sine, of course, is the opposite to the hypotenuse ratio. So the sine of 30 degrees is equal to what? 1/2. Over 1 or just a half, right? That's why we have that unit triangle there. Okay, the sine of 45 degrees is the opposite over the adjacent. I'm so sorry. Sorry, I'm looking. I thought it was doing tangent. Sine of 45 degrees is the opposite over the hypotenuse. So rad 2 over 2 over 1. So this is just rad 2 over 2. Wow, I messed that one up big time. I was looking at the wrong triangle. And then let's go back to the sine of 60 degrees. The sine of 60 degrees is going to be the opposite, which happens to be root 3 over 2 divided by 1. So the sine of 60 degrees is root 3 over 2. Notice all of these values are the exact value of these angles, okay? Root 3 over 2, right? It's the 60 degrees. It's the opposite over the hypotenuse. All right, great. Now, if you're going to do cosine, if you're going to consider cosine, which one's the easiest one to figure out? Do you think that's the easiest one? I think there's one easier. 45. Aren't they the same? So that has to be rad 2 over 2. And isn't it true that the cosine of 30 degrees has to equal the sine of 60 degrees? Because they are complementary cofunctions. So the cosine of 30 degrees would have to be what, you guys? Very good. Rad 3 over 2. Now let's check that. Let's go to 30 degrees. The cosine is the adjacent over the hypotenuse. There it is, rad 3 over 2. So what would the cosine of 60 degrees have to be? 1/2. Very good. Because it's an isosceles right triangle. Both legs are the same. Okay? Okay, what I'd like you to do, I'd like you to partner up. I'd like you to fill in the rest of the table. Please be sure to rationalize all denominators. Tangent of 30 degrees? Yeah, okay. So tangent of 30 degrees should be, you should have got the square root of 3 divided by 3. Okay? Now, the easiest ones in the world are right here. These are the easiest ones in the world. Why? Because they're both 1. Yes, they're both 1. Okay? So what would be the tangent of 60 degrees? Just the square root of 3. Very good. Now think about this. The cotangent of 30 has to be the tangent of 60, so this also has to be rad 3, right? And then vice versa, since the cotangent of 60 is equal to the tangent of 30 because they're cofunctions, then this has to be rad 3 over 3. Okay? All right, secant. Anybody get secant of 30 degrees? Yes, Daniel, what did you get? Correct. 2 rad 3 over 3. 45 degrees, yes. Rad 2 and 2. Very good. Therefore, the cosecant of 30 has to also be 2. This is rad 2, and then finally this is just 2 rad 3 over 3. Okay?
Can you leave it as 2 rad 3 over 3 for the secant of 60 degrees?
Secant of 60 degrees is 2.
Yeah, can you leave it as 2 rad 3 over 3?
No, it's not 2 rad 3 over 3. The secant of 60 degrees is 2. Yeah. All right, so this box is very, very, very important, okay? And these right here, the ones I'm highlighting for you right now, you guys, these are the need to know. Okay, these are the need to knows. These ones over here, the rest of them, those are nice to know. Okay, these are nice to know, but these are the need to knows, all right? So make yourself little note cards, have a little math party come over, quiz each other. Okay, you have a long time, so make flashcards, and please get that done. Okay, now, how do we use this information? What we're going to do is we're going to practice finding the exact value of these trig functions. So these are already written down in your notes so we can get through these, okay? So the sine of 45 degrees multiplied by the cosine of 45 degrees. Well, remember, 45 degrees is your friend. It's the easiest one of all of them to remember. Look, it's either rad 2 over 2 in both cases for sine and cosine, or it's a 1 for tangent. Couldn't be any easier. That one's your friend, okay? So when you see pi over 4 or you see 45 degrees, you are happy because it's only going to be one of 2 things, rad 2 over 2 or 1. So in this case, we're talking about the sine of 45 degrees is rad 2 over 2 multiplied by the cosine of 45 degrees, which is rad 2 over 2. Now, remember how to multiply square roots. The rad 2 times rad 2 is 2, and 2 times 2 is 4. Therefore, we have an answer of a half, and life couldn't be happier. What do you guys think about that? Pretty sweet, right? Okay. Tangent of pi over 4 minus the sine of pi, wait a minute, pi over 3. I think that button erased some important information for me. Tangent of pi over 4, ooh, our friend, we love that one. That's because it's 1. Minus the sine of pi over 3 would be? Good, yeah, 60 degrees, so rad 3 over 2. All you need to do now is make a fancy 1. Call that 2 over 2 minus rad 3 over 2, and that gives you 2 minus rad 3 over 2. And that's the answer we're looking for, the exact answer. So all that I did was I made a 1, a fancier 1, by making it 2 over 2. What do you guys think so far? Pretty good?
I don't like all the rads.
You love the rads. Rads are rad. Okay. Now, this one is number 37 of your homework problem set, so I'm doing one for you tonight, so please pay attention to this one. Right? We got 4 cosine times the 60 degrees minus 2 times the sine of 45 degrees. So we're going to have 4. What is the exact value for the cosine of 60 degrees? It is 1/2. Very good. Minus 2 times, hey, 45 degrees, it's a sine, so that has to be a rad 2 over 2. 4 times a half is just a half of 4, which would be 2. The 2's cancel out, of course, leaving me with a rad 2, and there it is. 2 minus rad 2. You guys thought I was going to mess that up, huh? Oh, that looks nice, Devin. Very good. Very good. Huh? I don't know. She just wanted to decorate. All right, and then let's do D. D is problem set number 41 of the homework, so if you need to refer to this one, you can come back to it, okay? Now, we've got a secant of pi over 4. Now, that's a nice to know one, so let's go back. What is the secant of pi over 4? That's a rad 2, plus 2. Cosecant of pi over 3, that's a nice to know. What would that one be? Cosecant of pi over 3. 2 rad 3 over 3. 2 rad 3 over 3. All right, so this one is going to take a little bit of effort. we're going to have the square root of 2 plus 4 times the square root of 3 over 3. We need to simplify this and make this one fraction. So, of course, we need a common denominator. The common denominator, of course, would be 3 in this case. So I'm going to multiply by a fancy 1 of 3 over 3. That is going to give me 3 square root of 2 plus 4 square root of 3, all divided by 3. And I cannot go any further. Please be aware, the square root of 2 and the square root of 3 are not combinable. They're relatively prime to one another. They have no common factors or anything like that. They are completely different. They're like x's and y's. So you leave it as 3 rad 2 plus 4 rad 3. Does that make sense?
Over 3.
Oh, it's okay. It's all right. Okay, and then my favorite one. Ooh, tangent pi over 4. We're happy. Why is that?
1.
Because that's a 1. So, ooh, cotangent pi over 4. We're happy.
1.
Oh my gosh. No, that was hard. That one's 2. Okay. All right, everybody. A little bit of fun review problem. Check it out. This bicycle wheel has a diameter of 68 centimeters. How far would the wheel travel in 1 revolution?
This was in the steeplechase.
Oh, cool. So, go ahead and try. Who thinks they have the right answer and can explain it? Gusland, go ahead. What do you got, buddy? The circumference would be, yes, 2 pi r. So the circumference would have to be 2 pi. What is the radius of this thing? 34 centimeters. So the circumference should be about what? 213.6 centimeters. Good. How many meters is that?
Well, 2.13.
No, how many meters is that? 2.13. Okay. So